Hello everybody, today we're going to do some real math, real Algebra 1. And in this chapter, or in this class, it's called Solving Linear Equations. Solving Linear Equations. Okay, there are two concepts I want to tell you. The first one is called an inverse operation. What is the inverse operation? Plus and minus, they are inverse operations of each other. So if you do 3 plus 5 equals 8, then 8 minus 5 equals 3. It's inverse operation. And the other one is multiplication and division. And these are inverse operation. And the other one is something square and the square root. That's also the inverse operation. So inverse operation. This is one operation. Okay, so they are in pairs, like we can tell here. All right, so this is the first thing we want to know. And the second thing, I want to introduce one concept. Concept is called equivalent. Equivalent equations. If there are two equations, they have exactly the same solution, then we call them equivalent. I'm sorry for this. Okay, equivalent equations. So those are the two concepts we introduced at the very beginning. Now, next, I'm going to talk about some key concepts about the equality. Okay. So, what is that? I hope you can remember. I use the equation to write it. If x minus a equals b, then I can plus a on both sides. Then a equals b plus a. All right. Now you see this. If x minus a equals b, what I'm saying is I can add the same amount, either the same number or the same expression on both sides. So if you add the plus a to this side, x minus a plus a, that will be just x. And then b plus a, which is this. Alright, so this is called, you can add the same number or the same amount on both sides of the equation, and then you get a equivalent equation. It makes sense? So this one and this one, they are equivalent equation. Every time we talk about equation, we talk about the left equals right. It's always left side equals the right side. Alright, so sometimes you might, if you look at this, you might hear when I say move a to the other side or move negative a to the other side, change the sign. See, if you move this negative a to the other side, change the sign. If you move a number from one side to another side, you have to change the sign of it. Therefore, you have x equals b plus a. So that is exactly another way to say the same thing. All right, so x equals b plus a, which is you move negative a to the other side, it becomes a positive a. All right, so later on, I can either say we plus a on both sides, or we can say move negative a to the other side and change the sign, make it a positive. So this is the first. Second property is if x plus a equals b. And then I'm going to add negative a on both sides. So I'm doing what? Inverse operation, isn't it? This is a plus a, so I do minus a, which is the inverse operation. And the good thing about this inverse operation, because we have the property about the addition of real numbers, plus a minus a, which is a 0. So x equals the right side is b minus a. Okay, so you can tell that I can either say minus a on both sides, or I can say move a to the other side to change the sign. It's exactly the same thing. All right, so what does that mean is, for example, if I give you x plus 4 equals 7, if I ask you to solve this equation, okay, and you can minus a 4 on both sides, then you can have x, this get cancelled, right? So you can have x equals 3. And the good thing is you can substitute this x equals 3 back to your original equation. You can check your answer. So that will be 3 plus 4 equals 7. Check, right? So you can check your answer. And so now you see what I'm saying here. You can either add a negative 4 on both sides or minus a 4 on both sides, or you can move this 4 to the other side. It becomes a 7 minus 4, which is a 3. Now, I don't want you to write this. I have seen so many students write this. When I ask him to solve x plus 4 equals 7, he just write that will be x equals 7 minus 4. That will be 3. You know, what is wrong here? This part is right. This part is right. But this is not equal. This two, this up to here, these two, they are equivalent equations, but you're not gonna say one equation equals to another. They are equivalent. So definitely don't put the equal sign here, because I've seen so many students write this. I cannot stand that. So don't do that. Every time you just do step by step, left equals right, left equals right, left side equals right side. Okay? So that's what you should do. And then we talk about the other two things about inverse operation. I think you can already figure out. If x divided by a equals b, and here a cannot be 0. I always write that when I have some denominator, the letters in the denominator, I always write that a is now 0, because if a equals 0, you cannot do this, right? All right, now if you have a divided by a equals b, then what you can do is you can multiply by a both sides. So you have x over a times a, x divided by a, now you times a. Do you see that's the inverse operation? And the right side is a b times a. Now x over a times a, and we know that we can cancel this out, right? A is now 0. So what do we have? We have x equals, and the right side is just ab. Okay. So did you see that every single step I have a reason, right? I have a reason, and I just put the equation like this: left side equals right side, left side equals right side. I don't just keep writing equal and then all the way to the answer. That's not right. All right, now the other way. If ax equals b, and I also give you a is not 0, then I can divide it by a on both sides. Ax over a, that will be just x, and the right side is a. That will be b over a. So you divide it by b on both sides, and a is now the 0, so you can divide it by that. And then after you write divided by a, use another line or start with a fresh start, okay, to write an equation. Don't write it equal. You don't write equal here. Now ax over a, that's x. B over a, that's b over a. So that's your answer. Did you see this? This is x times a, then you divide it by a. That's the inverse operation. All right, so now we have 4 things we know we can do. For an equation, we can add the same amount on both sides, or we can subtract the same amount to both sides, or we can multiply by the same number on both sides, or we can divide it each side by the same number. So we can do 4 things, and that new equation, after you do this plus minus multiply and divided by, the new equation still holds, and you get a equivalent equation. All right, now we're going to use quite some examples to practice all of this today. So after today's class, you can be proudly announce that. You can say that I know how to solve a linear equation. All right, I'm going to give you, we're going to work on some examples together. All right, so the first one, x plus 5 equals 12. If you have this linear equation and you have x plus 5 equals 12, and you're going to just like we learned earlier, we can perform the inverse operation here. So plus 5, so you're going to minus 5 on both sides. Therefore, you're going to get x equals, so plus 5 minus 5 get canceled out because they add up to 0. And here 12 minus 5, that's 7. All right, if you like, you can bring this x equals 7 back to your original equation. So 7 plus 5, that is 12. This is a very, very good way to solve it. Now number 2, okay, 3w equals 18. 3w equals 18. This is multiplication. Now this variable is w. Here is x. We might have any letters as the variable. We don't necessarily to have x. We might have a or b, or we have xy. Now we have w. So w is the letter we try to solve for that, right? We're going to solve for this equation, solve for w. So here, w times 3. 3x, which is 3 times w, or w times 3, equals 18. We're going to perform the opposite, or the inverse operation. So we are going to divide it by 3. 3w divided by 3, I just get a w, equals 18 divided by 3, I have a 6. All right, if I like, I can bring this w equals 6 back to this equation. 3w, 3 times 6, that is exactly 18. So I check, I get the answer. Okay, so let's work on the third one. Okay, 12 equals negative 3n. This one is a little different because the letter is on the right side. It doesn't really matter. If you like, you can switch the left and the right. You can do that. You can do negative 3n equals 12. If you don't, that's fine. That's totally fine, because at the end, you're going to switch that at the end. But anyway, so let me just switch that. And then we have a negative 3n equals 12. And here's the multiplication. So we're going to perform the inverse operation. We are going to divide it by negative 3. Divided by negative 3. Okay, don't get scared when you have a negative. Negative 3n over negative 3, that's an n, equals 12 divided by negative 3. Positive, negative, I should have a negative. 12 divided by 3, I get a 4. So my n is negative 4. Let me double check. If I put in n as negative 4 here, plug it back, I have a negative 3 times negative 4. Negative, negative, I get a positive, and a 3 times 4 is 12. So that's perfect. That's good. Sounds good? Yeah. Okay, so let's try one more. Okay. M minus 5 equals negative 10. Now, we are going to solve for m. And here is m minus 5 equals negative 10. So when m minus 5, what is the inverse operation of minus? That would be plus. So let's do this. So we're going to plus 5 to both sides. Then m minus 5 plus 5, that's m. And the right side, negative 10, positive 5. So if you go on the number line, you go to the left by 10 and go to the right by 5, you're going to stop at negative 5. Okay, so m equals negative 5. So minus 5, negative 5, minus 5 equals negative 10. We're good. We know how to solve for that equation, right? So we have tried this now. This is 1, 2, 3, 4. Let me give you some more questions and make it a little bit more complicated. Okay, here. That's 1, 2, 3, 4, 5. Okay, the example number 5 is 2x plus 1 equals 7. Did you notice the difference between this one and the previous 4 questions? There is a number in front of 2. Did you see that? So this is called a coefficient. Coefficient of the variable is 2. And for the previous 4 questions, all the coefficient of the variable is 1. So we have either just x or w or m, right? But now we have 2x. It doesn't matter. So we just keep that until the last step. So far we have plus 1. The first thing I need to do is I need to minus 1. Okay. Then I'm going to have a pretty clear or neat terms with just the x. So if I minus 1 on both sides, I will have 2x plus 1 minus 1 get canceled out. And then 7 minus 1, that's 6. All right, now it's much easier now because I have this 2x equals 6. This is a multiplication, so I'm going to divide it by 2. What do I have? X equals 3. Okay, if you want to double check, you plug in x equals 3 here. 2 times 3, which is 6, plus 1 is 7. So that's my answer. Sounds very good, isn't it? All right, so let's try one more. Okay, what about number 6? Okay, let me give you 2w plus 5w equals 35. It's not just one term with variable. We have 2 terms with variables. But the good thing is they are like terms. So our next step is we can just combine them. We combine like terms. 2w equals 5. 2w plus 5w, that is 7w equals 35. All right, now it's easy. Now it's w times 7, so we divide it by 7. Inverse operation. Then we have w equals 35 divided by 7. The answer is 5. So you can plug this back. 2 times 5 is 10. 5 times 5, 25. And 10 plus 25, that's 35. So you can check you get your answer right. So that's number 5 and 6. Let's work on number 5, 6, 7. Right. You ready? So we're going to have negative 16 equals 40 minus 8d. Wow, we got a d as the variable. And then well, you have 2 ways to do it. One is just keep doing, because I think the previous examples we switched the left and the right side. We move the variable terms to the left. But this time I'm going to keep that at the right, and then we're going to see what happened. This 4d minus 8d, they are like terms. So the left side is still negative 16, but the right side is 4d minus 8d, which is negative 4d. All right, now same idea, because here is a multiplication, so we're going to divide it by negative 4 on both sides. What do I have? On the right side, I have a d. On the left side, a negative 16 divided by negative 4, I have a positive 4. Okay, if you like, you can write at the end, you write d equals 4. So you can do the switching part at the very end. So you get a D equals a 4. All right, now number 8. Okay, we have y equals 5 minus 5 minus 2y. It's a little hard, huh? We have a y term here. We have a y term here. The general idea will be move all the terms with the variable to one side and everything without the variable to the other side. So, okay, I want you to see what I'm doing. I have plus 2y. I'm not just add a number. Do you remember when we talk about the properties at the very beginning? I said on both sides of the equation we can add the same number or the amount or the same thing. So this is that same thing. So this negative 2y plus 2y get cancelled out. The right side is just the 5. And the left side is y plus 2y. I can just combine them. I get a 3y. It's a little complicated, right? It's a little different. But until we finish that, we get this. Now we know exactly what should we do next. We just divide it by 3. Because here's a multiplication, and so we divide it by 3. Therefore, I get a y equals 5 over 3. Okay, and if you like, of course, you can write as 1 and 2/3. You can do that because the numerator is greater than the denominator. You can do that, but most of the case, if you write the answer like this, that will be right. So that's 5, 6, 7, 8. Okay, so let's work on a little bit more. We'll work on number 9. Okay, number 9 is, let me give you one example. 5m minus m plus 4 equals 12. We have more terms. Okay, so don't be scared. Just like what I said, you want to keep all the terms or move all the terms with the variable to one side and all the numbers to the other side. So in this case, I can do 5m minus m. I already know that. That is a 4m, isn't it? Okay, I combine like terms. I'm not changing anything. I can just write one more step, equals 12. Okay, and then the next step, I'm going to perform the inverse operation. I can minus a 4 on both sides. Then I have a 4m equals 8. Next step, divided by 4. Divided by 4. So you get m equals 2. Okay, now when you have this step, you said, well, here I have a 4. Can I just, not doing minus 4, let me divide it by 4. Can I do that? Of course you can do, but the problem is, sometimes if you have all those numbers, this time you're lucky because everything, all the number 4 and the 12 are divisible by 4. But sometimes if you have some different numbers, that will cause you trouble because you're going to get into a lot of fractions, and a lot of people don't like to work on the operation with fractions. Let me give you the example here. The good thing is if you have this divided by 4, 4m plus 4 divided by 4, the right side is 12 divided by 4. What do you have? Divided by 4, everything divided by 4, so you have m plus 1. Okay, so this 4 will cancel out with this 4, and also this 4, okay? And the right side is 3. Now you minus 1, minus 1. Okay, let me just write minus 1. So your m will be 2. You should get exactly the same answer, but it's just a little bit complicated. Okay, number 10. I'll give you one more thing. Okay, I get a 3/4 k minus a 6 equals 12. what are you going to do with this? We always try to find the easiest way. We try to find all the equations. I hope I can get rid of this, the 3/4, because I really don't like to deal with the fractions. How do you get rid of this? Remember, here is a plus, and you can divide it by that. And if you want to divide it by a fraction which is the same as you multiply by its reciprocal. Do you remember that? So what you need to do is you're going to multiply by 4/3. You just copy the equation left side. Okay, so 6. So you have this times 4/3. And the right side is going to be also 12. You have the times of 4/3. Again, don't keep writing equal, okay? They're not equal because you're changing the value. But you get the equivalent equation. So the reason you want to multiply by this reciprocal because you want to get rid of that. And you only have k minus 6 left. And the right side, 12, you cross out with this 3. You have a 4. And 4 times 4, that is 16. Okay. Next step will be easy, right? You you plus 6 on both sides. So you have k equals 22. Okay? So that's the number. That's a question number 10. Okay. All right. So a lot of people always get confused about how to multiply by the reciprocal of a fraction. So let's work on one more questions to make sure that everybody understands this. We have negative 4/5 times 4x minus 1 equals 32. Phew. It's very complicated, isn't it? All right, now if you look at this, first of all, it's a linear equation. The x, that's not a problem, the variable is x. But we have this number we try to get rid of. We want to get rid of negative 4/5. So we're going to multiply by the reciprocal of that. That is, you can multiply by negative 5/4, or you can just multiply by this negative, just 5/4. I would prefer to multiply by negative because this is negative. I want to cancel. I want to cancel them. 4x minus 1, and the right side is a 32 times negative 5/4. Okay, so we multiply by negative 5/4 on both sides. Perfect. I know this is gone, this is gone, and this is gone. See? So this part becomes 1. So 1 times anything is just that itself. So we have a 4x minus 1 equals, let's see what's the right side. 32, it's a negative. I'm going to get a negative number. And a 32 and an 8. 32 is 4 times 8. So I cross this out, I have an 8. Sounds good? So negative 5 times 8 is negative 40. Phew! Now I get all the integers, right? So next step, I'm going to plus 4, or you can say I move negative 1 to the other side, I get a positive 1. So I would have 4x equals negative 40 plus 1, I have a negative 39. And then the next step, divided by 4, that would be negative 39/4. That's your answer. Phew. It looks complicated, but once you're very clear in your mind, because this is the first thing you want to get rid of, and then you get rid of this, and then you get rid of this, you solve for x. Make sense? So this is number 11, and let's see. Do we need to work on about this? Yeah, let's do that. Number 12. It's a lot of questions we worked for, right? So we work on negative 14 equals 2 over 5 times 9 minus 2y. I'm looking for y. I need to solve for y. It's on the right side. And remember I said it doesn't really matter. You just go ahead and solve it, and then you can keep that at the right side, or you can put that on the left side in the last step. So let's just do that. Okay, first of all, I don't like this. I don't like this 2 over 5. So I am going to multiply by 5 over 2 on both sides. 5 over 2 times negative 14. I will do that, okay? So the good thing about this is on the right side, I have only 9 minus 2y. On the left side, this 2 and a negative 14 get cancelled. I have a negative 7, and a negative 7 times 5, that will be negative 35. It's very good so far. All right, now this is negative 2y, but here's a 9, so I'm going to subtract a 9 on both sides. Okay, and then the left side, negative 35, negative 9, I get a negative 44, right? And the right side, I have a negative 2y. Okay, already I can see the light in the tunnel. At the end of the tunnel, we can just divide it by negative 2, and the right side I will have y, and the left side a negative 44 divided by negative 2, I have a 22. Therefore my y at the answer is just 22. Okay, so we have learned how to solve all the linear equations, no matter what the equation look like, right? Even it's kind of like this, and if we have the variable on both sides, and we move all the variables to one side and the number to the other side, so we know how to do this, and we learn how to use the inverse operation and to move things around. I call that move things around. Okay, so this is how to solve the linear equation. Step 1, or the part 1. Okay, as a part of this solving linear equations, we want to learn this, how to write ratios and proportions. Now we need to know ratio. What is the ratio? A ratio means you're going to compare two numbers or two quantities or two expressions or two things. Okay, so the ratio, if you have an A to B, it's a ratio. Usually you see that in like a basketball game, right? A football game, and what's the score? 14 to 21, or something like that. Is A to B. You can also write A to B. This is also read as A to B. We use 2 dots, and also it's the same as A over B. Now this is a word, right? A to B, 14 to 21, and this is A colon 21, so A to B. But this A over B is actually a number, isn't it? Like a 14 to 21, and we can even simplify that. That becomes what? 2 to 3. Okay, that's 2 touchdowns to 3 touchdowns. It's interesting, isn't it? Okay, so let's see. A volleyball team. Let me give you one example. Okay, a volleyball team played 5 home games. 5 home games. Okay, and how many away games? 2 away games. Okay, So if I ask you, what is the ratio of home games to away games? That will be 5 to 2. Okay, so home game to away game, home game to away game. All right. Now, and what is the ratio of a home game to all games? So altogether, he played 7 games. So home game to all games. So that's home to away. And this is home to all. Okay, so this is the way to write it. This is the 5 to 2. You can also write 5 to 2. You can 5 to 7. Okay, it's the same thing. All right, so this is the general idea about the ratio. Then the ratio. After a ratio, we learn what is a proportion. Proportion is an equation that states 2 ratios are equivalent. Okay, so the general form of that would be A over B, A to B is the same as C to D. Here, B and D are not 0, okay? Because we don't want the denominator to be 0. And this is a proportion, proportional to each other. It was like a 2 touchdown to 3 touchdown. It's the same as a 14 to 21. It makes sense? They have the same ratio amount. The final answer is the same. So when you have things like this, and then there's one thing you probably have heard, it's very important, it's called a cross product. Cross product, which is this. That is A times D will be the same as a B times C. Okay, for example, if I ask you for x over 5 equals 4 over 10. It's not a very good one. 2 over 25. That's better. This is better. Okay, so cross this out. So if I give you this is also a equation. This is a linear equation because here we have the x term and the x exponent is just 1 x, okay? No x squared, no square root of x, and no x in the denominator. So that will be the linear equation. So we have x over 5 equals 2 over 25. Now how do you solve for this? If you have a ratio, a fraction, they're the same. If you write them like this format, use the cross product. So that means 25 times x. 25 times x, this 2, should be the same as 2 times 5. Here's the times, okay. That's 10. So 25x equals 10. Can you solve it? Of course, you can just divide it by 25. Okay, so you have x equals 10 over 25. We have the common factor of 5. So that would be 5, 2 over 5. Done. So we can solve it. And of course, just like we learned earlier, you have x over 5 equals 2 over 25. This is x divided by 5. And then we perform the inverse operation, which means we're going to multiply by 5. So you're going to have x equals 2 times 5 over 25, right? This is 2 over 25, and you multiply by 5. So this 5 canceled out, you get a 5. So you also have x equals 2 over 5. These two are exactly the same thing. Okay, so the cross multiplication, the cross multiply, which is a very, very useful tool or very useful skill, I would say. Skill or something that you can remember. Okay, so let's work on a couple of more examples. I forgot the number. We have 1, 2, 3, 4, all the way to 12. It's all right. So we just use 1 again. All right. Let's see. M over 36 equals 5 over 6. How do you solve this? You have two ways to do it. One is m divided by 36. The first method, you're going to multiply by 36 on both sides. And that canceled out, you just get m. The second method is cross multiplication. 6 times m equals 5 times 36. Let's use both way, okay, to see what happened. First, we multiply by 36 on both sides. 36 equals 5 over 6, also times 36. And the left side of this 36 will be gone. You have m. And the right side, this is 6 and the 36 get cancelled. You have a 6. So 5 times 6, that is a 30. So this is what we're using, is what we learned earlier, that we perform the inverse operation. The other one, we use cross multiplication. So this becomes 6m equals, now 5 times 36. 5 times 36. 6m will be 5 times 36 is 180. And then I divide it by 6. Divided by 6. So my m will be 30. You see that? We got exactly the same answer. Okay, so this is how to solve that. Now, what about this one? If I put things in writing, I said solve the proportion. Okay, what I'm saying is 5 is to 7 as a is to 28. This is 5 is to 7 as a. This is a. Is to 40. Is to 28. So how do you write that? You write 5 over 7 equals a over 28. Now, I really hope that you can remember how do you interpret this in English. 5 is to 7 as a is to 28. So this that's the proportion, right? These two ratio, they are the same. They have the same value. Now you can multiply by 28, or you can use cross multiplication. Let's use cross multiplication. I got a 7a equals 5 times 28. 5 times 28 is 140. Now, did you notice that I didn't write equal here? Don't write equal, because they're not equal, okay? They're equivalent, but they're not equal. Then the next step is you divide it by 7. So you have a equals 140 over 7. That would be 20. So that's your answer. All right. So this is a very important, is how do you read the sentence? How do you interpret this into English? 5 is to 7 as a is to 28. Why this thing is so important? Because when you take the examination in like a SAT or what else, or some other standardized test, or some other algebra one, when you read it, they usually read things like this. So you have to know, when they talk about this, 5 is to 7 as a is to 28. This is how you write this. Remember, for algebra 1, which is the first class you should learn your elementary school math, that you are going to be a good translator. You're going to translate between English and math. All right, now, so we did ratio and proportion. All right, let's work on something complicated. Okay, so 3 over x equals 2 over x minus 6. Ooh, you might get scared. You said, why I have x in the denominator? Yeah, Yeah, but don't worry, we know how to solve it because we have a fraction type of thing on the left and also another one on the right. So that was A over B equals C over D, that type of question. So what we're going to do is we're going to cross multiply. So cross multiply 2 and x, I have 2x equals, that will be this times that. So that's a 3 times x minus 6. Wow, they are testing us a lot of things, huh? So I have a 2x on the left side, and the right side, I can use the distributive property. So I get a 3x minus 18. You see this distributive property? Do you remember that, right? Okay, this is not bad. So I am going to minus a 3x on both sides because then this side will be just no x. And it seems like I move all the x term to one side by doing so. So 2x minus a 3x, I have negative x equals, on the right side I only have negative 18. So obviously I divided by negative 1 or multiply by negative 1 or just simply change the sign on both sides. In other words, if you want to change the sign on both sides, which is equivalent to your either multiply by negative 1 or divided by negative 1. So x equals 18. Okay. So this is pretty hard, huh? Okay, so let's work on one more. All right. Okay, we do k over 5 equals 4, okay, k minus 6. I just made that up. How to solve for that? Cross multiplication, we're the expert now. We know 4k equals 5 times k minus 6. And I know 4k equals 5k minus 30. You see how I get this 30? Distributive property. Right? Alright, now the next step I'm going to minus 5k because I really want to get rid of this on the right side. So I have a negative k equals negative 30. We are so good at this. Okay, will be just 30. Alright. So we are going to work on the most complicated one question, then we're going to move to the next, okay? So we're going to do this. It's a huge number. Okay. X plus 3. Okay, x minus 32 equals 9 over 2. So don't be scared. Cross multiply. Okay, so 2 times x plus 3 equals 9 times x minus 32. Big number, huh? Distributive property. See, we're so good at that. So I have a 2x plus 6 equals 9x minus, well, 9 times 32, that's a big number. 88. Okay. You can either do this, 32 times 9, 2 times 9, that's 18, 3 times 9, 27, and then plus this 1, I get a 28. Okay. Or you can use calculator. Alright, so we have this. Phew. What are we going to do next? I will minus 9x on both sides, and also I will minus a 6 on both sides. Can I do that? Yes. I do that at the same time. See? I add or subtract the same amount on both sides. On the left side, this plus 6 minus 6 canceled out, so I have a negative 7x equals. And the right side, there's going to be no more x, so this becomes negative 288 minus 6 becomes 294. Wow. Well, the next part is easy, divided by negative 7. So let's see if you remember 294 divided by 7. This is something that you learned a long time ago, isn't it? I think definitely in like elementary, maybe grade 3 or 4. So that's a 4 times 7, that's 28. And I have a 14, so it's going to be 2. 14, 0, I'm done. So the x becomes 42. Okay. This is the most complicated question that you're going to see when we talk about ratio, fraction, cross multiplication, solve linear equation, things like this. Okay, the most complicated one. All right. Usually after you learn about ratio, the next thing you want to know is this, is percent. And do you know this? 100%. What is 100%? 100% is 1. All right. What is 20%? 20% is 20 over 100. And you simplify this, you get a 1/5. If you write this as a fraction, or if you want to write as decimal, it's going to be 0.2. Okay, so I think a lot of books, they have like the whole session, they ask you to do the conversion between the percent to fraction to decimal, decimal to fraction, fraction to decimal, fraction to percent, percent to fraction, all things like this. Now you just need to remember this percent means divided by 100, and everything will be easy. For example, can you write like 15% as a fraction? That will be 15 over 100. Over 100. I'm going too fast. And then I found that both numerator and denominator are divisible by 5, so I divided by 5 top, divided by 5 bottom, and I cannot simplify any further. So I'm converting this fraction of this percent to this fraction. And if I ask you to write 15% into decimal, that will be just move the decimal point from here to the left by 2, so you have 0.15. Okay, so there are all several ways to convert it, the percent, fractions, and the decimals. That's usually, it's like a big deal. Right now, why we want to know this? I want to know something. Do you remember when we talk about what are the key words that are going to use to determine like a multiplication or addition, subtraction, multiplication, division? There's one important thing. I did mention that a little earlier, but I don't know if you remember this. For multiplication, there's a very important keyword is of. For example, 15% of 40, which means 15% times 40. Okay. This of means times. Then how do you find that? You can write this 15 over 100, or you can just write a 0.15 times 40. And then of course you can go ahead and simplify. You get this is a 3, this is 20, and then 20 cross out with this is 4, you get 2 here, so the answer is a 6. So what is a 15% of a 40? 6. All right, so you're gonna say 15% of 40 is 6. Or the other way, 6 is 15% of 40. It was exactly the same thing. Okay, let's look at this question. What number is 40% of 150? What number is 40% of 150? So we're asking for x equals 40% times 150. That's an equation, isn't it? X equals something. So x equals 40%, I can write that as 0.4 times 150. The answer is 60. So 60 is 40% of 150. How about if I change the question and say what percent of 150 is 60? Okay, what percent? So I'm asking for x percent of 150 is 60. Remember, x percent is x over 100. Remember that. Times 150 equals 60. Okay, now this is a linear equation, and what we can do is we can multiply by 100 on both sides. Multiply by 100 on both sides, because I want to cancel that. And we divide it by 150 on both sides, because I want to cancel this. Okay, so I have x equals what? 60 times 100 divided by 150. And this 100 and 150 both are divisible by 50, so that'll be 2 over 3. And this 3 can cross out with this 60. I have a 20. So 20 times 2x is 40. Now, if I bring this back, what percent of 150 is 60? The answer is 40% of 150 is 60. You see this? Okay, so this is how you translate the percentage question into a math equation. That's a linear equation, and then you're going to go ahead and solve it and answer the question. Okay, so that's the percent question. And the other thing is, let me ask you this: what number is 87.5% of 512? Okay, how do you solve that? Okay, if you want to do this question, you can just say x equals 85.5% times 512. You can use calculator to do it. Now let me give you the question as a standard multiple choice. Okay, standard test. A 5.85, B 448, C 585, D 4480. This is a very typical standard test question. Now, what number is 87.5% of 512? Is that less than 100%, right? So if it's less than 100% of 512, the number should be smaller than 512. So this, no good. This, both numbers, C and D, are greater than 512. So 87.5% should be less than that. Can that be 5 that small? Of course not. Okay, because 512, even 500, 80% will be just 80. So this one is too small. So this is the only possible answer. See, you can either use your calculator or you can use your hand to figure out this to get the answer, or you can use the we call this elimination method. We get rid of the wrong answer and we check the right answer. Okay, so if you are going to use the calculator, let me bring the calculator here. Okay, if you have the calculator, oops, the calculator is too big. So let me just press that. Okay, so it's going to 87.5% is 0.875. That's 87.5%. Of 512 is times 512. See, 448, that's the answer. So during your examination, if I just ask you this question, then you give me the answer, it's going to be 448. But if you're given the multiple choice questions, you can get the answer faster. That's what I'm saying. Okay, so that sounds good. All right, now we're going to deal with the last part of it. We call that rewrite equations and formulas. What does that mean? Rewrite equations and formulas. This is so useful. When you learn physics or chemistry or some other subjects, they're going to use this a lot. What does that mean? Which means this. Which means, for example, if I give you A equals B plus C, and I want to rewrite it as B equals what? Okay, so sometimes you see this case, you don't really have numbers, and maybe you have a number, but anyway, so I'm asking for some letter. So now you're going to treat all the other letters as a given amount, given value, or given stuff. And only this one, the B, will be the variable. So you're going to solve just like you're doing with the linear equations we learned earlier. So you're going to solve B. Then in this case, you need to solve B, so you have to subtract a C on both sides. So your B will be just A minus C. Done. Okay, that's called rewrite equations or formulas. Another example is about the temperature change. So we know this F, the Fahrenheit. Okay, Fahrenheit is 32 plus 1.8 C. This is a Celsius. This is a very typical equation, right? So if I ask you to solve for C equals what? I am rewriting this equation, or I am rewriting this formula. How should I do that? I subtract 32 on both sides. So I will have F minus 32 equals 1.8 C. And then I need to solve for C, so I divide it by 1.8. Divided by 1.8. Therefore, C equals, I switch the side, okay? Equals F minus 32 divided by 1.8. See? You get a new formula. This is the given formula or equation. We use C to calculate F. We rewrite that so we can use F to calculate a C. Is that a good example? Yeah. We can do this quite a lot. For example, we know the triangle. If you have a triangle like that, here's the base, here's the height, here's the 90 degree. Okay, the area of this triangle is this. Area equals 1/2 of base times height, isn't it? Okay, so let me just use this as A. I call this capital A. That's 1/2 BH. All right, now let me rewrite that. Let me get a B. How should I do this? This is 1/2. So let me multiply by 2 on both sides. So this 1/2 will be gone. And then I will have 2A equals BH. And I'm looking for B. I have an h here, which is multiplication, so I will divide it by h. Then my b will be, that will be just 2a over h. Okay, so this is a given area, given height. Can you find the base, the length of base? Yes. Okay, so that's this one. It's very interesting. The idea is exactly the same as you're dealing with numbers. The only difference is you are going to have all the letters, and you just treat them as numbers and use exactly the same idea we learned earlier. Plus, minus the same amount, or multiply by or divided by the same amount on both sides. So you can get that. Okay. So I think we just do one more. Let's work on one more question. All right. I will ask you to solve for x. Given ax plus b equals cx plus d. Can you solve for x? Okay, just treat this a, b, c, d are numbers, so don't worry about them. What do we need at the end? We need to know x equals what. Okay, solve for x. So remember, we're going to move all the x term to one side, so we're going to subtract cx on both sides, and then move all the numbers without x to another side. So I'm going to minus b, I'm going to minus b. All right, so by doing this, the left side I have ax minus cx equals, and this is gone, so I have a d minus b. All right, first job done. Already move all the x term to one side and all the numbers without all the terms without x to another side. Now the next one, I'm going to combine like terms. Remember here we have x as the variable. What is 7x minus 2x? That will be 7 minus 2, so you get 5x, right? So the same idea, we have a minus c of x. Did you see that? This is from here to here is the distributive property. From here to here is the opposite. I call that a factor. So I get an x out, and then inside I have a minus c, and on the right side I have a d minus b. Then the next one I'm going to divide, next step I'm going to do it divided by a minus c. Divided by a minus c. Okay, and that canceled out. So my answer x will be d is b over a minus c. All right, whew, this is good. Okay, now we solved it. You might ask, why we want to do that? Okay, let me tell you why. If I ask you to solve an equation, 2x plus 5 equals 3x minus 9. Okay, for example, I just give you this. That's the same, right? ax plus b equals cx plus d. In this case, a is 2, b is 5, c is 3, and d is negative 9. Let me just plug into here. I have x equals, what is a d minus b? D minus b, that's negative 9, negative 5, divided by a minus c, that's 2 minus 3. So I have a negative 14 over negative 1 is 14. I get this right away. Okay, so this is the general form of the equation. I use a, b, c, d to represent the numbers, and then go ahead and solve for x. This is like the formula. Once I have this real numbers, the real numbers doesn't really mean that real numbers. I have the actual numbers here, a, b, c, d. I can just plug in this, and I can calculate any equation with this form. And then I just figure out what is a, what is b, what is c, what is d, and then I put in this formula, I can get that answer. So that's a general idea of it. And so far we have done everything for solve linear equation. You should be really proud of yourself. This is very hard for the new Algebra 1 student. This is really hard, and I'm so glad you know how to do this right now. And I hope you can find more exercise. If you're looking for more exercises or you look for more questions, you can either find any Algebra 1 textbook, or you can send me an email and ask for it. I'll be very happy to provide you a lot of questions. All right, so that's all for today's class. See you next time.